This is my second video on writing chemical equations. This time, what I'm looking to do is to write equations from scratch. Now, this is a higher level skill and will tend only to be asked on the higher tier papers. To do this, there are three parts. First of all, you need to use the correct pattern to name the products. As before then, you have to write the formula of the reactants and products, as we've done through writing chemical formula. And it's important to remember two things. The formula of diatomic gases are H2, O2, N2, F2, Cl2, Br2 and I2. And it's also important to remember the formula of common acids and ammonia. So hydrochloric acid is HCl, nitric acid is HNO3, sulfuric acid is H2SO4, and ammonia is NH3. And then the last thing then is just like we've done in the first equation, is to balance the equation. Now, here are some of the common patterns which will help us to predict the products. So, a metal reacts with oxygen to form a metal oxide. A metal reacts with an acid to form a salt plus hydrogen. Acids react with bases to produce salts and water. Acids react with carbonates to give you salts, carbon dioxide and water. And then there are, if you like, the reactivity equations. A more reactive metal will displace a less reactive metal from its compound. And then more reactive metals will reduce less reactive metals from their oxides. And the last one then is if you burn a fuel with a plentiful supply of oxygen, you'll always find carbon dioxide and water. Now, these aren't all the patterns that you'll come across, but ones to get us going. So let's start. So for our first example, we've got zinc reacts with oxygen to form zinc oxide. So there we've got our zinc plus oxygen go to zinc oxide. And there's our pattern. Metal plus oxygen forms metal oxide. Now, then we need to write the formulas. Now, zinc, because it's an element on its own, it's just Zn. Oxygen, as we said, is one of those diatomic gases, as written as O2. And then zinc oxide. Now, if we look at the charges on zinc, so zinc is charged +2, oxide is -2. So, as these cancel out, that formula is balanced. Now, what I'm going to do, as before, I've got one zinc atom, oxygen molecule, like so, zinc and oxygen. Now, normally I say always leave the oxygens to last, because if you balance everything else, it'll all fall into place. But it's quite obvious here, we've got two oxygens here, but we've only got one here. So we need another zinc oxide. Now, we've now got two zincs here and only one here, so we need another zinc. So in terms of balancing, we've got 2 zincs react with one oxygen molecule to give you 2 lots of zinc oxide. So that equation is balanced. Let's look at the next one now. So we've got magnesium Magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen. So, magnesium plus hydrochloric acid, and this is the pattern of acid plus metal, forms a salt plus hydrogen. And the salt, as we see here, is magnesium chloride. And the other product is hydrogen. So let's put our symbols and formulas in. So magnesium as an element on its own, Mg. Hydrochloric acid is one of those I said that you need to learn. Its formula is HCl. I'm going to jump to the end here. Hydrogen, because it's one of those diatomic gases, has to be written as H2. And then let's look at the magnesium chloride. Now, charge on magnesium is +2. Charge on chloride is -1. So the lowest number they will both go into is 2. So 2 goes into 2 once, 1 goes into 2 twice. So the formula of magnesium chloride is MgCl2. Now, let's do our usual balancing drawing up. So we've got 1 magnesium, we've got hydrogen, we've got chlorine, we've got magnesium, and 2 chlorines, we've got 2 hydrogens. Now, 1 magnesium, 1 magnesium, so they're balanced. 1 hydrogen, 2 hydrogens. So obviously we need another hydrogen, which means we've got to put another molecule of hydrogen chloride. So 2 chlorines, 2 chlorines. So there's... So finally the balancing now. 1 magnesium, we've got 2 molecules of hydrochloric acid, so 2 in front there. We've only got 1 of magnesium chloride and only 1 of hydrogen, so there we're fully balanced there. So last example now, silver nitrate. So we've got silver nitrate reacts with copper to form copper nitrate and silver. So silver nitrate reacts with copper, our reactants, form copper nitrate and silver. So silver nitrate plus copper forms copper nitrate plus silver, and this is one of our displacement reactions which based upon the reactivity series, and this works because copper is more reactive than silver. Right, so let's go for this. Silver. So if we look for silver, silver is Ag plus, so it's +1. Nitrate. Nitrate, as we can see, is NO3 minus. Now, because they're equal and opposite, they cancel each other out, so it's balanced. Copper. It's an element, so there's no charges there. Let's just deal with the silver there. It's an element, no charges there. Now, let's look at the copper nitrate. So, Copper, as we can see, is +2. Nitrate, already we know, is -1. Now, the lowest number that will both go into is 2. So 2 goes into 2 once, 1 goes into 2 twice. Now, if you remember from your formulas, when an ion is made up of more than one atom, and it occurs more than once, it has to be put in a bracket, and that 2 outside the bracket. So let's look at the balancing. So we've got silver, Ag, NO3. We've got copper, so we've got copper here. Now we've got 2 lots of nitrate. So N, O, 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 N, O, 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 and 1 lot of silver. Now, in terms of balancing, let's start with coppers. 1 copper, 1 copper. 1 silver, 1 silver. So that looks like okay so far. Now, let's look at the nitrogens. 1 nitrogen, 2 nitrogens. So we will need 2 lots of silver nitrate. So the nitrogens are happy now. In total now we've got 3 6 oxygens. We've got 3 6 oxygens there. Now we've got 2 silvers here and only 1 here. So we need another silver there. So in terms of the balancing, we've got 2 molecules of silver nitrate, 1 of copper, going to 1 of copper nitrate, and 2 atoms of silver. Now, that's the most complicated type where we've got brackets, which you see by leaving the options to last, everything else just falls into place. So, good luck with further balancing and writing your own equations. I hope this has helped.